Our final example, we're going to be seeing an example of applying a system of equations in business. Okay? A vendor at a carnival sells cotton candy and caramel apples for $2 each. All right. The vendor is charged $100 to set up his booth. Furthermore, the vendor's average cost for each product he produces is approximately 75 cents. So, keeping all of that in mind, we want to write a linear cost function for part A that represents the cost, C of X in dollars, to the vendor to produce X products and also to set up his booth. Okay? So, his cost function, C of X, it's going to cost him, it says, 75 cents per product. So 0.75, that's the unit cost, times the number of products sold. That is how much it costs him to produce these caramel apples and also cotton candy. And then if he's going to set up this booth, it also costs him $100. So that's his total cost if he's going to be like selling this stuff and making this stuff and selling this stuff. On part B, it says write a linear revenue function representing the revenue, R of X in dollars, for selling X products. Well, he's going to sell those for $2 each. So his revenue that he earns for selling X products is $2 each times the number of products, X. So 2X. Now, this says to, on part C, determine the number of products to be sold. Determine X. X is the number of products to be sold for the vendor to break even. Now, you know the vendor is going to break even when costs are equal to revenue. Okay? So, when cost is equal to revenue, that is when his cost of 0.75x plus 100 is equal to 2x. So we're going to solve this equation, costs equal revenue, for x. First of all, subtract 0.75x from both sides. And we will have 100 equals 2 times $2 times 75 cents is $1.25. So 125x. Now divide both sides by $1.25. Divide by $1.25. And so let's see. 100 divided by $1.25 is 80. Okay? So if he can sell more than 80 products, he's going to start making money. 80 products is the break-even point, okay? And when he, just by the way, his revenue at 80 products is $160, okay? And that's going to be the same thing as the cost of producing 80 products. That's also going to be $160 if you want to check that as well. So then with that information in mind, it says if 60 products are sold, will the vendor make money or lose money? He's going to lose money because his break-even point was 80 products. He only sold 60. So he's going to lose money here. Does that make sense? Okay, concepts, here we go. 2 or more linear equations taken together make up a system of linear equations. A blank to a system of equations in 2 variables is an ordered pair that is a solution to each individual equation of a system. The solution to a system of equations is the XY ordered pair that checks in both of them, okay? Number 3, 2 algebraic models to solve a system of linear equations in two variables are the blank method and the blank method. All right, well, we have the graphing method, but in this section, a little bit better, you know, is the substitution. And the other one is called either the addition or elimination. This book called it the addition method. Number 4, a system of linear equations in two variables may have no solution. In such case, the equations are going to represent parallel lines. A system of equations that has no solution. If it has no solution, it is called a blank system. What type of system? Inconsistent. Okay, number 6 says a system of linear equations in two variables may have infinitely many solutions. That's when one line lied right on top of another line, right? Okay. It says in such a case, the equations within that system are said to be what type of equations? Dependent. All right, there's section 9.1. Get this down, and then we'll take it to linear equations in three variables in the next section.